Hello, myself OP Srivastava is going to explain regarding successive differentiation in this video. मैं ओपी श्रीवास्तव इस वीडियो में सक्सेसिव डिफरेंशिएशन क्या होता है, कैसे निकाला जाता है, इस सारी बातों पर जोर डालूंगा, उसको समझाऊंगा. ओके, although I have already explained what is successive differentiation on the screen, but let us start from very beginning. So I am just offing it now again. Successive differentiation. What is successive differentiation? If a function, say y is function of x, means value of y depends on value of x, then rate of change of y with respect to x is known as dy dx, rather derivative of x y with respect to x, or sometimes it is also written as y1, sometimes written as dy dx, sometimes written as f dash x. Now suppose f dash is again a function which can be differentiated, okay, which can be differentiated. Then its next differentiation is known as d2y dx2 or f double dash x or y2. Similarly, if y2 is again differentiable, then its next differentiation will be known as y3 or d3y dx3 or f3, f and dash 3x. Okay. In this way, these all are known as successive derivative. For example, here I have mentioned it. If y is function of x, then dy dx or f dash x or even y1 is called first derivative. d2y dx2, f dash x or y2 also is known as second derivative. d3y dx3 or f triple dash x, here must be triple dash x too, known as third derivative. So if we arrange, I can show you f dash is the first derivative, f double dash x the second derivative, and triple dash x is third derivative. Or in terms of dy dx, it is dy dx is the first derivative, d2y dx2 is the second derivative, d3y dx3 is the third derivative, d4y dx4 is fourth derivative, and so on. It can also be mentioned as y1, y2, y3 up to y and so on. Suppose y is not the variable, some other variable is there. So I am generalize dy dx, d2 dx2, d3y dx3, and like that. So this way, if a function can be differentiated again and again, then the process is known as successive differentiation, and the derivatives are known as successive derivatives. Okay. Let us do a working example. I'm just showing it you. Here, suppose y is equal to ax plus b whole power the 5. We want to get its successive derivatives. So y is equal to ax plus b whole power the 5. If you get its first derivative, I mean dy dx or y1 or f dash x, that gives you 5 into a into x plus b whole power the 4. Now it is again differentiable, again differentiated. That will be known as second derivative. I mean d2y dx2. y2 or f double dash x 5 into 4 into a square ax plus b whole power the 3. In fact, keep in mind this 5a into x plus b whole power the 5 is the first derivative of ax plus b power the 5, and 5 into 4 into a square ax plus b whole cube is the second derivative of ax plus b whole power the 5, but it is the first derivative of 5a into ax plus b power the 4. Mind it. And so on. So y3 means third derivative of ax plus b power the 5 is equal to 5 into 4 into 3 into a cube ax plus b whole square. The fourth derivative of ax plus b power the 5 is equal to d4y dx4 rather y4r f4 f4x is equal to 5 4 3 2 a power the 4 into x plus b. Similarly, fifth derivative is 5 into 4 into 3 into 2 into a power the 5, and sixth derivative is 0. Right? Now, I am going to find out the nth derivative if possible of some important function. So let us start that. I am talking about problem 1. Here it is. find the nth derivative of important function, that is if y is equal to ax plus b whole power the n belongs to natural number, is a positive number, then what is yn? What is the nth derivative of y? So let us find out its first derivative. Y is equal to ax plus b whole power the 1, whole power the n, sorry. Then dy dx is equal to y1 is equal to f dash x is n into a into x plus b power the n minus 1. If you get y2, it is again differentiable. So let us find out this y2, I mean second derivative d2y dx2, that n into n minus 1 into a square ax plus b power the n minus 1. Again it is differentiable. So let us find out third derivative d3y dx3 or rather y3, n into n minus 1 into n minus 2 into a cube into ax plus b whole power the n minus 3. Similarly, fourth derivative is n into n minus 1 into n minus 2 n minus 3 a power the 4 ax plus b power the n minus 4. So mth derivative ym is equal to n into n minus 1 n minus 2 n minus 3 into n minus m minus 1. I am following the pattern. Here is 4, so it is here 4, but here is 3. Similarly, a power mth derivative is a power the m here, n minus m minus 1, where m is less than or equal to n belongs to a natural number. On this basis, if you want to find out nth derivative, the yn is equal to fnx, n into n minus 1, n minus 2, n minus 3, last में n into n minus 1. That becomes 1 in fact, into a power the n, ax plus b power the n minus n, and factorial into a power the, and that is the nth derivative. Right? Alright. Let us take another example. Problem 2 I am talking. Y is equal to fx 1 upon ax plus b power the minus 1. Then yn. Now, as y is equal to 1 upon x plus b is equal to x plus b power the minus 1. Then the first derivative dy dx is equal to y1 is equal to f dash x is equal to minus 1 into a into x plus b power the minus 2. d2y dx2 y2 is equal to f double dash x minus 1 into minus 2 into a square into x plus b power the minus 3. Now arranging it, minus 1 is here, minus is here, so minus 1 square, 1 into 2 into a square, ax plus b power the minus 3. This 1 into 2 becomes factorial 2. So minus 1 square into factorial 2 into a square into x plus b power the minus 3. On this pattern, if we get y3 or rather d3 by dx3, we get minus 1 cube factorial 3a cube into ax plus b power the minus 4. Fourth derivative y4 is equal to minus 1 power the 4 factorial 4a power the 4ax plus b power the minus 5. On the similar pattern, dny dx n, rather nth derivative yn is equal to minus 1 power the n factorial n into ax a power the n into ax plus b whole power the minus n plus 1. So if it is y, then it is the yn. It is possible only when, because y1 is again differentiable, y2 is again differentiable, and so on. Now let us discuss another problem, problem 3 I am talking it as. Y is equal to log ax plus b. So yn is what? So y is equal to fx is equal to log ax plus b. So dy dx is equal to y1 is equal to f dash x is equal to 1 upon ax plus b, and after differentiating x plus b we get a. So a into x plus b power the minus 1. It is some way related to the previous problem. So y2 d2y dx2 is equal to minus 1 into a square into ax plus b power the minus 2. d3y dx3 y3 is equal to minus 1 into minus 2 into a cube into x plus b power the minus 3. Rather again minus 1 into 1 into 2 a cube ax plus b power the minus 3, rather minus 1 square into factorial 2 into a cube into ax plus b power the minus 3. Now d4y dx4 rather fourth derivative. That is minus 1 minus 2 minus 3 into a power the 4, that gives you minus 1 cube 1 into 2 into 3 into a power the 4 into x plus b power the minus 4 It means it is minus 1 cube into factorial 3 into a power the 4 ax plus b power the minus 4. Now, in the similar pattern, if you want to know nth derivative, that is dn y dx n, yn is equal to minus 1 power the n minus 1 factorial n minus 1 into a power the n into x plus b power the minus n. So, on the similar pattern, I got this. Okay. Now, suppose on this basis you want to know the sixth derivative, d6 dy dx 6 is equal to minus 1 power the 5, 6 minus 1 is 5, factorial 5 into a power the 5 into x plus b power the minus 5. Right? Alright. Now, see some other problem also. Problem number 4. Y is equal to fx into e power the ax plus b, then what is y? Now, y is equal to fx is equal to e power the x plus b. So, first derivative dy dx y1 is equal to f dash x is equal to a into e power the x plus b. Second derivative d2y dx2 is equal to, again differentiate it, you will get a into a power the ax plus b, that becomes a square into e power the ax plus b. Third derivative, similarly a3 into e power the x plus b. If you follow the same pattern, the nth derivative dny dx is equal to dny dx n is equal to a power the n into e power the ax plus b. Now let us say some trigonometrical function. Okay. Now I am taking this time y is equal to fx, yani sin ax plus b. Then what is y? Y is equal to sin ax plus b implies that its first derivative dy dx is equal to y1 is equal to f dash x is equal to a into sin का हो जाएगा cosine ax plus b. Now again rearrange it, a into ax cosine x plus b can be written as a into sine pi by 2 plus ax plus b. Differentiate it to get the second derivative, that becomes a square sine का cosine pi by 2 plus ax plus b. Arrange it again in sine form, a square sine pi by 2 plus pi by 2 ax plus b, that gives you a square sine 2 into pi by 2 into x plus b. Third derivative similarly, sine का हो जाएगा cosine a cube cosine 2 into pi by 2 plus ax plus b. Arrange it again, you will get a cube into sine pi by 2 plus 2 into pi by 2 sine ax plus b, that gives you a cube sine 3 pi by 2 into x plus b. Now see, third derivative is here 3. So fourth derivative it will have here 4. I mean a power the 4 sine 4 pi by 2 ax plus b. On the similar pattern, if you want to get the nth derivative, dny dx power the n is equal to a power the n sine n into pi by 2 plus ax plus b. It's very simple. The only thing is to remember that when you will differentiate sine, you will get cosine. Arrange cosine again in front of sine, and then we will make a pattern of it. Right? So it is sine ax now ax plus b. Now let us take cosine ax plus b. Problem here. If y is equal to fx equal to cosine ax plus b, then what is y? Y is equal to cosine ax plus b implies that dy dx is equal to y1. I mean first derivative is y1 is equal to f dash x is equal to derivative of cosine is minus sine, so minus a into sine ax plus b. Arrange this sign in terms of cosine. That becomes a into cosine pi by 2 plus ax plus b. Sin pi by 2 theta is equal to minus sine theta on that basis. Now get the second derivative d2y dx to y2. Differentiate this only. We'll get minus a square cosine ka sine pi by 2 ax plus b. Arrange it in term of cosine. That is a square cosine pi by 2 plus pi by 2 ax plus b. That is a square into cos 2 into pi by 2 into x plus b. Now get the third derivative by differentiating this. Y3 is equal to minus a cube sine 2 into pi by 2 ax plus b. Arrange in terms of cosine, you will get a cube sine pi by 2 plus, because sine pi by 2 theta, cosine pi by 2 plus theta is equal to minus sin theta. So a cube cosine pi by 2 plus 2 into pi by 2 ax plus b is equal to a cube cosine 3 into pi by 2 into x plus b. Similarly, the fourth derivative will become a power the 4 cosine 4 pi by 2 plus ax plus b. On the similar pattern, if you want to get the nth derivative, that will become dny dxn is equal to yn is equal to minus a power the n sine n minus 1 pi by 2. Mind it, here 4 derivative, then here it is 3. Third derivative, here it is 2. On the similar pattern I have mentioned it. A square minus a power the n sine minus n minus 1 pi by 2 x plus b. Again add a pi by 2, you will get a power then cosine n into pi by 2 into x plus b. Okay. In my next video, I will solve some numerical also on based on this nth derivatives, finding nth derivatives and successive differentiation. So please follow my videos. Okay, one thing. Second thing, if you have your any special problem, please mail me. My mail address is omrdso@gmail.com, and feel free. It is all free. Not a single penny you have to pay. Okay. So feel free and mail me and ask the problems by mailing me. Okay. So follow my videos. The other videos are also there. So thank you. Thank you for watching.